This is the final video for Unit 6 integration. We're going to learn U substitution, Unit 6.9. Okay, so these are your basic integral forms here on the left. You have to know these by heart and you have to know these really well. These are the opposites of derivatives. For example, the integral of sine is negative cosine. And if you look at negative cosine and you take its derivative, the derivative of cosine is negative sine. But since we have this negative out here, those negatives will turn into a positive, and you're left back with sine. Also, the integral of cosine is sine because if you take the derivative of sine, you get back to cosine. E to the x is e to the x, whether you take the derivative or the integral. Over here, if you have 1 over u, that is log of u. Make sure it is an absolute value, because if you take the derivative of log, you end up with 1 over x. And finally, if you take the integral of any base to a power, you add 1 to that power and divide by the new exponent, as long as it's not a -1 exponent, because you would have to refer back to the natural log. So when you're integrating, make sure it's always in the form where you just have an x inside. If not, if it has like a 2x inside, you cannot say the integral of cosine of 2x is equal to sine of 2x. And it's because of the chain rule. Notice that the integral of sine is cosine, but the integral of 2 cosine is not the same thing as 2 sine. And here's the reason why. If you take the derivative of cosine of 2x, you get sine of 2x times, because of the chain rule, the derivative of 2x, which is 2. And so that's why these don't work this way. This is why we have to have what we call U substitution, which is basically the reverse of chain rule. So the hardest thing about U substitution is figuring out what U is and what we need to substitute for U. Usually it's just a more complicated expression that's in here in the parentheses, right? It'll be like, instead of e to the x, it might be e to the x squared or e to the 2x. Instead of x to the -1, it's 3x to the -1. So anything of that form, instead of something to a power or something to an exponent, it's like, parentheses 3x plus 1 to the second power. Okay, so moving on. So here are the strategies for U substitution, and this will make sense as we do examples. But the first thing is to always find U and then take its derivative as the second step. Now, after you do both of those, you're going to solve for dx. And again, this will make sense when we do examples. And then you basically substitute what you found in steps 1, 2, and 3 back into the equation. And then once you do, you're going to get something like this. So one of these 5. And then you take its integral, and then you have to substitute back in for x. So let's do this example right here. So this is a simple one. We're going to say, because we know what the integral of sine of u is, but not sine of 2x. So we're going to let u equal 2x. That's our step 1. Our step 2 is to take its derivative. So we have du equals 2 dx. So step 3 is to solve for dx. And so if we divide by 2 on each side, we get that dx is du over 2. So again, with this expression, you divide by 2 on each side, you'll get dx by itself. Now, we have an expression for dx here, and we have an expression for u that goes in here. So let's substitute all of that back in. So we have the integral of 2 sine. And again, we're going to use u instead of 2x. So again, we substitute u into here. And then we're going to substitute dx for du over 2. And now Look what happens after we do our substitution. Those cancel, the 2's cancel, and we are just left with the integral of sine of u. And we know how to do this function, or this integral. And notice there is no x's left. That's one thing. So make sure all the variables are in the form of u. So now the integral of sine is negative cosine of u plus c. And we are almost done. We do have to substitute back for x. And in this case, we knew that u is equal to 2x. So this is going to be negative cosine of 2x plus c. And that is my integral. And you can kind of see if we take its derivative. If we take a derivative of cosine of 2x, that would be negative sine. With this negative, makes it positive. And then we would have to take the chain rule and multiply it by 2, and we'd get this 2 back. So that works. So notice, looking at here, we have to figure out what u is. Now, usually it is whatever's inside of the parentheses or the brackets. So in this case, we're going to let u equal x cubed plus 1. Now we're going to take its derivative, so du is equal to 3x squared plus 0 dx. Now if I solve for dx, all I have to do is divide each side by 3x squared. And that is steps 1, 2, and 3. Now we have to sub everything back in to our original equation. So now we have everything in u almost. Now, whatever you have here with when you substitute for dx needs to cancel out with the remaining x's you have. And in this case, it does. So the x squareds cancel. Now we're left with the integral of 1 over square root of u times 3. And constants are fine. We can pull constants outside, and we'll write this as a negative exponent. And we're back at a power rule. So now, to do this integral, we're going to add 1 to negative 1/2, and then divide by the new exponent, which is 1/2. We'll simplify this by reciprocating and multiplying this outside. And we are almost done. The last thing we need to do is substitute our original x back in. So this is going to equal 6 times the square root of x cubed plus 1, and then we always add our plus c at the end. So looking at example 3, we know the integral of e to the x, but we need to get it into that form. So it looks like this is what's holding us up. So we're going to let u equal x squared minus 1. And then du, if we take the derivative of each side, we're going to get 2x dx. And then solve for dx. Now we are going to substitute everything back into our equation. So again, instead of x squared minus 1, we're going to write u. And then instead of dx, we're going to write du over 2x. Now, everything after this should cancel that's an x. And in this case, it does. So if I rewrite my formula, I'm going to pull out the 1/2 outside. And we're just left with e to the u du. Now, the integral of e to the u, it's just e to the u again. We always have our plus c at the end. And then substitute u back, or x back in for u. And that is my answer for example 3. So this one's a little harder. You do have to see that this right here, if I put this in parentheses, that's to the first power. And so I can rewrite this. Again, I'm going to move the 3 outside because it is a constant. This will be 1 over 4 minus 2x to the first. And then I'm going to write that as a negative exponent. Okay, so now in this form, it makes it a little easier because I know a -1 is basically a log. Like I want to try to get this to u to the negative 1 because I can integrate it as a log. So I'm going to let u equal 4 minus 2x in this case. My du in this case is going to be, again, if I take the derivative of 4, I get 0. And if I take the derivative of 2x, I just get 2. So du is equal to negative 2 dx. And then if I solve for dx, I get du over 2. So this gets substituted in for dx. And we're going to substitute u in for 4 minus 2x. So this is going to be u to the negative 1. Okay, so now, again, this is a constant. I'm going to pull this outside. And we know that u to the negative 1 is basically 1 over u. And so if we take that integral, it's going to be natural log of u, and then add your c. And then so our last step is to substitute our u back in, or substitute our x back in. And that was 4 minus 2x. And there is our integral. So kind of similar to the last problem. This is what's kind of holding this up. We can move the negative 4 out in front because it is a constant. So we're going to let u equal 5 plus 3x. My du is going to be 0 because the derivative of 5 is 0. And the derivative of 3x is 3. And then if I solve for dx by dividing by 3, I get that my dx is now du over 3. And so let's substitute back in. Again, here's my u. And then my du, my dx is du over 3. So now I'm going to pull out the 3, and I'm going to rewrite this as a negative 2. So we have, this is a power function with an exponent. We are just going to add 1. We're going to add 1 to the exponent, so that gives me u to the negative 1. And then divide by negative 1. This negative comes out here, turns that positive. And then substitute whatever x back in for u. And then my final answer is going to be 4 divided by 3 times 5 plus 3x. And then always add your constant out at the very end. Question 6. So this one involves a u substitution, but only for this part. Notice how cosine, we already know the integral of cosine. So I'm going to use one of my properties and split the integral up into these two. And so we already know the integral of cosine. The integral of cosine is just sine of x. No u substitution required. But we will do a u substitution for sine of 3x. We'll let u equal 3x. Du is going to equal to 3 dx. And then if I solve, I'm going to get du over 3 is dx. So this, if I substitute everything in, will be sine of u and then du over 3. I'm going to pull out this 3 outside to make it 1/3. And we know that the integral of sine of u is negative cosine of u. And then if you substitute your 3x back in, you're going to get negative 1/3 cosine of 3x. Again, u is equal to 3x. Don't forget the sign we already did. And then you do have to add a plus c at the end. So all of these that we did before were indefinite integrals. Notice that there was no boundaries. So our next example is to do integrals with boundaries of a to b. And it is the same exact process, except we have one extra thing to do. So here are your kind of 3 components of an integral. You have your limits of integration from a to b. You also have your, what we call the integrand, which is f of x. And the variable of integration is dx. Now, each of these have to be with the same variable. These two are values of x. This function's a value of x, and we're integrating in the value of x. So when you do your u substitution, you need to change your limits of integration. And that's the one extra step you have to do. So let's look at example 7. So anything, look at a parenthesis. The parenthesis is here. So if this was u cubed, we can find that integral pretty easily. So we're going to let u equal x squared plus 4. Take its derivative. The derivative of x squared is 2x dx. And then if we solve for dx, we get du over 2x. So substitute dx and u into our equation, our integral, I'm sorry. From here, the 2x's cancel, which is great. And now we need to change the limits of integration again. So this is from 1 to 0 with x's. So we're just going to plug in 1 into here to find our new u, and then plug in 0 into here to find the new u. So I will show up here. This will be 1 squared plus 4, which is technically 5. And this will be 0 squared plus 4, which is 4. So my new integral is from 4 to 5 of u cubed du. So if I do my integral, add 1 to the 3 to make it a 4, and then divide by 4. And then usually you would substitute back in for x and then find your thing. But since we have new variables, I'm going to plug in 5 and then plug in 4, and we will subtract those. So 5 to the 4th power is 625. 4 to the 4th power is 256. And then if you subtract those numerators, you're going to get 369 over 4. And that is my definite integral. That is the area under the curve from 1 to 0. So now number 8, we're going to use our trig functions. So we're going to let u equal 2x. Our du is going to be 2 dx. And then solving, we're going to get du over 2 is dx. So substitute your variables in. That's going to be sine of u, and then du over 2. And I'll highlight them just so you see where everything is going. And also, we do need to substitute in our boundaries. So 2 times pi over 2 is going to equal pi. That is my new boundary. And then 2 times pi over 6 is pi over 3. And so that's my new lower boundary. So from here, now that we did our substitution, let's take the integral, but also let's pull out this 1/2 outside. So the integral of sine is negative cosine of u. And we're going to evaluate that from pi to pi over 3. And just to make this easier, I'm going to pull the negative outside as well. So cosine of pi is going to be -1 minus cosine of pi over 3, which is 1/2. So -1 minus 1/2 is going to be -3/2. And then if I multiply that by the -1/2 again, I'm going to get 3/4. Now you might also want to know, Busby, why are you not adding a plus c when you do the integral? And the reason is because, so if this had a plus c attached to it, we would have a plus c here and a plus c here. But notice this c is going to be subtracted from this c, and it's going to cancel out. So whenever you're doing definite integrals, the c's cancel. So you don't need to write them when you're actually taking your limits with boundaries. Okay, example 9. So we have an e. We want to get this to the form where it's e to the x. I'm going to let u equal x cubed minus 1. Take the derivative of each side, you get du on the left. And on the right, you're going to get 3x squared dx. Solve for dx by dividing by 3x squared. And we have all of our substitutions. And I guess let's do the boundaries. So if I plug in 2, that's going to give me 7. And if I plug in -1, that's going to give me -2. Again, -1 cubed is -1, -1 is -2. Okay, and then just to make sure, my variables cancel, which is good. And then I'm going to pull out the 1/3 outside. Now, the integral of e to the u is just e to the u. That's why we love these. Makes them easy. And then we want to substitute 7 and -2 in. So if I substitute 7 in, I'm going to get e to the 7 minus e to the -2. And that is good enough. We're not going to simplify anymore. Okay, last example. It says, by using this u substitution, 2 sine of x, can you simplify this expression? Well, we have our 2 sine of x there. So it already did all the work for us. This isn't a multiple choice question off an AP test. So if I take the derivative, I'm going to get 2, and the derivative of cosine, or sine is cosine of x dx. Simplify. So we have our dx, we have our u. So let's look at our integral. Oh, I'm sorry. And then do your boundaries. I almost forgot the boundaries. So u is going to be equal to 2 sine of pi over 2. And again, I'm just substituting these boundaries into here. Sine of pi over 2 is 1 times 2 is 2. Plug in, we need to substitute 0 back in for our boundaries. And the sine of 0 is just 0. So this new integral is going to be from 0 to 2 of cosine of x times the square root of u. And then dx is going to be du over 2 cosine of x. Now, the cosines of x cancel. We are going to pull out the 2 outside. And this is going to be u to the -1/2. This is going to be u to the 1/2. Now, since we have this, we're just going to add 1. So 1 plus 1/2 is 3/2, and then divide. So we'll have u to the 3/2 divided by 3/2. And I actually did too much work. That's not what the question was asking. The question was asking about the u substitution, which is right there. That is D. I got excited and I was going a little bit further.